Hello friends, Objective 1, Verma and friction will be discussed in this video and my name is Hitesh Sharma obviously. So let's get started. Start with question number 1. In a situation, the contact force by a rough horizontal surface on a body placed on it has some constant magnitude. If the angle between the force and the vertical is decreased, we have to find that the frictional force between the surface and the body will increase or decrease. So by contact force we means resultant of normal and friction force. Okay, by contact force we means resultant of friction and normal force. So if the angle between this normal and total contact force is decreasing, means tan theta, which is Fr by n, will be decreasing, so friction should decrease as normal will remain same because it is on a horizontal plane at rest. So normal is just balancing mg, so normal will remain mg. So as theta decreases, friction must decrease. Okay, let's move on to the next question. While walking on ice, one should take small steps to avoid slipping because small steps require small friction, because ice cannot provide you large friction if you will try to take a large step which ultimately requires a large friction, and ice will not be able to provide you that, so you will slip. So ice can provide only a small friction, and with the help of small friction you can only take small steps. So small steps are taken because ice can provide smaller friction only. The next question, there is a body of mass m which is kept on a rough horizontal surface, coefficient of friction mu. Person is trying to pull the object by applying a horizontal force, but the body is not moving. So we have to find the force by the surface on A is F. This is again the total contact force resultant of normal and friction force. So which of the following is most appropriate? Let's look at the diagram. Normal, mg, this friction force, and here should be a force applied by the man. So F is nothing but resultant of these two forces. Normal will remain mg because no vertical acceleration, but friction will increase as the force applied here will increase from 0 to mu mg. Okay, so that resultant, which is F, and that is resultant of friction and normal. F is nothing but resultant of normal and friction. So F will be least when friction is least, which is 0, and F will be max when friction is max, which is mu s mg. Okay, so this is the maximum value of that total contact force, and this is the minimum value of that total contact force. So C is the only option correct. A scooter is starting from rest, moves with a constant acceleration for time delta t1, then with a constant velocity for time delta t2, then again deaccelerate for delta t3 time, finally comes to rest. Weight of man is 500 Newton, and he managed to stay at rest with respect to the scooter without touching any other part. The force exerted by the seat on the man. Again, whenever the scooter is accelerating, the friction will provide that acceleration, whether it is in the forward direction or it is in the backward direction while it is slowing down. Okay, so friction will act in the interval delta t1 and delta t3, but there will be no friction when there will be no acceleration, and that is interval t2. So in interval t2, the total contact force will be simply normal, which is mg. But in interval t1 and t3, the total contact force is the resultant of friction, which is not 0 in this case, and normal, which is 500. So in interval t1 and t3, total contact force will be greater than 500, and in the interval t2 it will be simply 500 Newton. So the correct option is option D. In the next question, there's a situation, the wall is smooth but the surface A and B are in contact. are rough. The friction on B due to A in equilibrium. So this is the FBD of the question. This is the FBD of block B, in which force, normal reaction, and weight of it is applied. If B has to be in equilibrium, then the friction on B by A must be in upward direction. Okay, only then it can be in equilibrium. So the friction on A by B, which is just reaction of this force, should be in downward direction on A. So A has two forces in downward direction, MAG and this friction on A by B, but the wall is not able to provide any friction because it is smooth. So A cannot be in equilibrium in this situation. Hence, the equilibrium is not possible when the wall is smooth. Okay. In the next question, when the wall is rough, we can say the wall will provide this upward friction on A, and the rest forces will be in the same direction as explained earlier. Okay, so friction on B due to A should be in upward direction. On B due to A should be in upward direction. Okay, next is two cars of unequal masses use similar tires. If they are moving with same initial speed, the minimum stopping distance obviously will be same, because to stop we can use the maximum retardation friction can provide is mu g, as mu is same because the material of the tire is same. So it is independent of the mass, we can say. So both will stop in the same distance. They have same initial velocity, same retardation, so they will cover same distance to stop. Okay. In order to stop a car in shortest distance on a horizontal road, one should apply brakes such that you can provide limiting friction. Okay, so apply brakes very hard? No. Otherwise, if you will apply brakes very hard, the car will slip and kinetic friction will act, which is less than the limiting friction. You should apply brakes hard enough to just prevent slipping. Yes, option B is correct one. Pump the brakes, press and release? No, this should not be done. But option B, yes, theoretically option B is correct, but it is very very hard to say that, hard to do this, because when you are pressing the brakes you cannot be very sure that this is the maximum friction or this car is about to slip. You will came to know when the car will slip itself. Okay, so option B is theoretically correct, but when you will talk to a driver, he will say that I used to do option C. Okay, but we are studying physics, uh, not driving a truck, so option B is the theoretically correct answer. Okay, shutting the engine is not at all an option. Okay, because the truck will continue to go with very large speed, almost unretarded. Question number 9. Block A is kept on an incline, just begin to slides. If the inclination is 30, the block is replaced by another block. It is found that it just begin to slide if inclination is 40. Okay, so the sliding is independent of the mass. For sliding, tan theta should be greater than mu. So we can say mu between A and surface is smaller than mu between B and surface. Okay, so it is independent of mass, so we'll go with option D. Let's talk about the next question. In the last question, there's a boy of mass m which is applying a horizontal force to slide a box of mass m dash on a rough horizontal surface. The coefficient of friction between the shoe of the boy and the floor is mu, and the coefficient of friction between the box and the floor is mu dash. In which of the following case it is certainly not able to slide the box? Okay, let's have a look at the diagram of block and the boy. They are applying normal reaction forces to each other. This is the force applied by boy on block, and this is the reaction of that force on boy by block. Okay, so block don't want to slide, so friction will be provided on block from ground, and obviously boy will also get some friction force from ground. Okay, so basically these are the two equal forces on the buoyant block, N and N. So they will slide when friction, uh, the in which case when the friction of one object will be greater than maximum friction will be greater than maximum friction of another object, the object having smaller value of maximum friction will slide. Okay, so if fr dash friction, maximum friction on the block, is greater than maximum friction of the buoy, then obviously the block will not slide. If the buoy push the board block harder, he will slide himself. Okay, so maximum friction on the block is mu dash m dash g, and maximum friction on the buoy is mu m g. G has been cancelled, so mu dash m dash must be greater than mu m for block not to slide. This case will certainly occur if both mu dash and m dash are greater than mu and m, and that is option E. Okay, thank you. Enjoy.